Good afternoon, eBayers. Today we're looking at a whole range of problems across these paraffin inverter heaters. They continuously come up with E1, E4, E3, E2, just no end of measure of E-faults. There are several different sorts of them on the market and they all suffer with this problem. And if not at first, certainly after a little while. And I've done a video before showing the problem is that the flame sensor, it needs to be cleaned with a wire wool or something like some wet and dry or something like that. But the trouble is, because paraffin these days is not pure as well, you are supposed to only use a special paraffin in them anyway, which is very pure, but we don't do. Let's face it, we use ordinary paraffin in them, and the problem with that is that it builds up a film on these flame sensors. Now we've got to get rid of this problem once and for all, so I've just about had enough of it. And there is a way to do it as well, and it's very simple. So we've got our flame sensor. This is our flame sensor. It's directly in the flame from the burner that would be about here, and they very often glow bright red, which is quite normal for them, but again, because they're glowing red, they tend to carbonize slightly. Now there is a resistance, a very small resistance, between the burner and the flame sensor as it warms up. I mean, it's caused by the carbon in the flame itself. You can't read this resistance. It's not. So you have to use a meter in microamps for it. Now, manufacturers are quite happy with 10 microamps. 10 microamps or more, they're happy. They usually have a cut-off actually about 60 microamps, which would indicate a fault error and shut the heater down as well. You know, I'm going to be using a brand new heater today, and it's had no more than 15 minutes use. And I expect that to chuck out a good 20, maybe 30 even microamps. But we'll see what happens anyway. But what we're going to do is we're going to take the line that goes from, if I can get my hands out of the way for you, take the line that goes from the flame sensor, and we're going to put that into the base of a PNP transistor like this, and the emitter of it, we're going to put a 1 meg resistor, and then that's going to go to ground. The collector is going to go off to the processor where this one was going originally. So we've just chopped it and put this little circuit on board. It doesn't require any micro board or Vera board or anything complicated. It requires 10 minutes of your time, a little bit of heat shrink, and that's all you need. And it will sit there round about should be around about the 40 microamps mark. But the good thing about it is, although you might get 40 microamps before even possibly, if you have a build-up of film on this flame sensor, it will still maintain that 40 microamps. So you don't have to take it apart and clean it all the time, which is a bloody tedious job, I can tell you. So that keeps that stable at around about 40 milliamps. But if there's a break in this cable, or the flame goes out, that will then drop this right straight back down to nothing, and the safety trips will trip in, the heater will turn off. Otherwise you'll have hot paraffin spraying into the burner chamber and nothing there to ignite it. It would just be, you know, it's dangerous as hell. It could, you know, couldn't be worse. So without further ado, let's get a heater on the bench, and we'll take a reading before we put this little mod in, and then we'll make the mod and we'll take a reading after. So I mean, don't expect a world of difference, because this resistor will reduce it down to around about the 40-ish microamps. If you didn't have that resistor there, it would go up to around about 65, and at 60 the processor would assume a fault and shut the heater down. So you need that there to maintain its safety. Right, without any further ado, let's get a heater on the bench and start taking it apart. Okay, here we have one Kero heater, very much the same as all of the others, and they vary a little bit on their wattage output, but it works on exactly the same principle. Let's just get it apart. There we go. Let's zoom in a little bit on this, and we'll take a little tour around it and see what we can see. Some nice important parts here. This is the aluminium heater that heats the paraffin up, this whole thing, and it gets hot. This is the thermostat for adjusting that temperature. It keeps it constant. Here we have the injector, which goes around here, down here, and to a pump. Pump's controlled by the CPU. This is the HT coil. Some coils are mounted actually back up under there, but this one's mounted on the board. That goes along there, and that goes to a spark inducer. Okay, these are the components we're going to be using. There's nothing special about them at all. You've got a 1 meg resistor here, and an ordinary PNP switching transistor here. A ZTX 500 will do. Although this is a BC number on here. It's a BC 3271G. Okay, it's a very, very common transistor, but it's any transistor will do it really, just about any transistor at all. Right, so we're going to start off with the sorry, a piece of heat shrink like this. Let me just pan back now. I mean, zoom back. I'm not very good at this. All we need to do is to connect it. By the way, the pinouts on this are collector, base, emitter, so it's straightforward CBE, can't get it wrong. It's just collector, base, emitter. Collector goes to your earth via the 1 meg. Base goes to your flame rod, and the emitter goes out to your to the actual, or to that wire there, which is to the processor. So I'm just going to bend these about a little bit and solder that resistor on so you can see it, and then we'll put it in line. Okay, here's our little device with the resistor added. As you can see, the collector has just been bent straight up the side of it, and the emitter has been bent straight up the side of it, and the resistor added to it, and the base just goes straight out of the middle of it. So we're all actually ready to put this in place. Right, so I'm going to start off with the collector, because the collector is the part that goes out to the main processor. So here's our collector wire. Just a bit of a bend in it so I can get onto it. That's got the collector done. And last but not least, and we'll just solder that on there. That's on its collector. The base then takes the wire that comes straight from the flame sensor. So that is the one that goes to the middle of this transistor. That's got the collector done. And last but not least, the emitter, which has got the resistor on it. We go to the opposite side of the resistor. Now that's it. That's the installation done. But for these purposes, what we're going to do is we're going to take off a wire or two and measure it for you, because you've seen what it was before we done this mod. It'd be nice to see what it is now we've done the mod. So I'm just going to take off the wire that goes off to the CPU. Okay, so it's connected up with the meter in line going to the CPU, which I'll just put this in front of you. This is the circuit that it is, and just here that goes to the meter, and then the meter returns to the CPU. Fan started. Ignition. 24, 25. Okay, this is the minimum. and that's 0.03, which is basically when it's turned off. This is the average, 21.6789 going up, and this is the maximum, 37, and this is real time. So there's not a huge amount of difference between the device being fitted and not being fitted, but where it gains is it does it when there's a build up on the flame bar or the flame sensor, it still holds its current. But we're gonna have to prove in a minute that we'll give it a few minutes. We're going to have to prove that if the flame were to go out, which would be the same as disconnecting the flame sensor, then the unit would shut down. Because if that didn't happen, then we'd be very remiss in our duties, because it couldn't be more dangerous. If you weren't in the room and it's pumped paraffin, hot paraffin all over the floor, and then it tries to ignite itself, everything will go up. Well, I know I'm repeating myself saying that, it's just I really want to get that through to you, that there are ways of bypassing these sensors very easily actually, but if you do it, you do it at your own risk. Well, I'm just going to sit here quietly now and let 5 minutes go by, and after which we'll test its ability to shut down under a fault condition. Okay, there we can see two rods glowing. There, rather. First rod is the igniter rod, which goes to the HT. Second rod that's glowed bright red there is our flame rod. And so you can see if it's something that's getting that hot and cold and hot and cold and hot and cold, how it can build up a film, which is why they recommend purified paraffin on these heaters. But we don't use it, nobody does. We use paraffin where we can get it. It's hard to get these days. So it builds up a film on it. With the by adding two components to this, the problem will be gone. Let me zoom back. Wow, this camera's got really hot being that close to it. But as you can see, we're averaging 33.5. Well, it's been well over 5 minutes and it has settled down now, because you can't hear any more bleeping coming from the meter, and the meter only bleeps as it goes higher. So there we have it. It's settled down a maximum of 44.32 An average of 39.82, which is what the CPU will be looking at. A minimum of 3, which is when it started up. And it's running at 42, blah 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 blah. Just to keep it happy. We're going to now simulate a fault. A fault being taken off the wire that goes, that will be going to the CPU. So it's this one. And that will simulate there being no flame. Although, in actual fact, really, to simulate there being no flame, we should take off this wire, which is the wire going to the flame sensor. So we're going to take that off, and it's off. Readings have gone straight down, plummeting down. The alarm has sounded. E2 is showing on the top of it. You couldn't ask for better. That totally solves this problem. So what I'm going to do now is put it together, as it were. Base wires on. And we're going to put the CPU wire on. Just need a bit of solder. Burn myself. CPU wires on. This is the piece of heat shrink that I slipped on earlier. Just to get something to shrink that. That is it. Job is done. Let me just show you this remote control system that I've stuck on it. It's just that white box there. What it does is I've tapped off 12 volts from a 12 volt regulator on the board. Although a lot of these boxes you can actually get them that run on 240 volts, which means you just bang it straight on 240. Now, because this heater's got an off and an on switch, two of them, you need a 2-channel RF transmitter and receiver. So I got this one, which is just A and B. A is on, B is off. And all that happens is there's 2 relays in there. You take the 2 wires off the relays and wire them to the back of the switches, the on and the off switch. So on is A and off is B, and that's it. Well, that's obviously going to go down and down and down now.